Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. We've talked about the confidence interval and what it means and how it connects to the hypothesis testing. So now let's do something more concrete, constructing a confidence interval. And the good news is you already know all of the ingredients or the pieces that need to be put together in order for you to construct the confidence interval. So let's do this step by step. Step one should be start with the estimate. Every confidence interval starts with an estimate. You will get this from a regression, let's say an estimated coefficient beta hat, because that is your best guess based on the sample that you observed. But keep in mind, that single number hides uncertainty, and that's what the confidence interval is going to give you information on. So again, it could be, for example, from a regression. Beta hat. The second step would be measure uncertainty with the standard error. Because as we said, every single number hides some uncertainty behind it. So the standard error of that particular estimate will measure how much the estimate would vary across repeated samples. How much it varies across repeated samples. So large standard errors would mean that you have noisy estimates. Okay, and small standard errors, precise estimates. So this is why the variance has been such a central concept throughout all of these series. The next step, choose a confidence level. And that can be 90%, 95%, or 99%. So these are the ones that you see most of the time. Keep in mind, sometimes they might be different from here, but these are like the most three standard numbers that you will see. And just a reminder from the previous video, the confidence level tells us how often this procedure captures the true parameter across repeated samples, which means in this case, again, higher confidence, wider intervals, lower confidence, narrower intervals. The next step is get the critical value. So you need to translate uncertainty into a range. For that, you need a critical value from the distribution. And in most regression settings, you're either going to use a t-distribution, and the most important thing is make sure you get with the appropriate degrees of freedom. Because the critical value tells you how many standard errors you move away from the estimate. After getting all of these ingredients, it's time to piece it all together and construct the confidence interval through this simple structure, which I have put in a box here for you. Estimate plus minus critical value times the standard error. And this plus minus in here means exactly that you will have to compute two numbers in here. So keep in mind, a confidence interval is just 1 point estimate. It was a range, so you need a minimum and a maximum. And by doing this plus minus, it means like you're moving, well, more or less around that number. It's like the margin of error, and that will reflect the sampling variability and the chosen confidence level. Let's go through all of these steps with a numerical example. So we're going to assume that all of the numbers that I'm going to say going forward is what we observe after running a regression and doing a study. So suppose that our beta hat is actually 2, and in the same table where I get my beta hat, I also have information on the standard error of the beta hat being 0.5. Let's say that out of all of these 3 most standard default confidence level, I pick 95%. which would give me a critical value for step 4, which is approximately 2. Okay, so it's 196, but depending also on the degrees of freedom, let's just say approximately that is 2. Okay, so now it's time to piece it all together. And remember, we had estimate, which is 2, plus minus the critical value of 2 times 0.5, which means that I have two numbers that I am computing. So I have 2 minus 2 times 0.5 and 2 plus 2 times 0.5. So ultimately, this confidence interval is just 1, 3. Interpretation? Well, this interval tells us that values between 1 and 3 are plausible given the data and the model. However, keep in mind that it does not say that all values are equally likely, okay? The true value is random. That also is not what this confidence interval is saying, okay? So, does not say that all values are equally likely. And it does not say the true value is random. Okay? The uncertainty comes from the data, not the parameter. So what changes the width of an interval? Now that you have all of the steps, now that you have all of the ingredients, answering that question also becomes a lot easier. So there are 3 things that will determine how wide or narrow this confidence interval is, and that includes the standard error, that includes the confidence level, and also the sample size, because remember, that is also going to define the critical value when you look through your table, okay? Plus the sample size also will affect your standard errors. So very important. And this connects everything back to the variance, sample size, and information that we have seen consistently through this little mini arc of hypothesis testing and confidence interval. Again, a reminder, a confidence interval is a point estimate explained by a margin of error that reflects uncertainty. I hope this was helpful, especially in terms of like how to calculate and construct confidence intervals. In the next video, we'll see how confidence intervals are often misinterpreted and how to avoid those mistakes. So make sure you look back at the previous video on the introduction of the confidence interval, and I'll see you in the next video.